Hey guys, welcome back. This is motor control, a review of first year concepts. Because we're going into motor control to begin with our second year level material, we need to review the first year content. So today, one of the things I've noticed in the labs and in the past is that we struggle with taking a diagram and figuring out how to wire it. It can get very messy, it can get difficult. In the field you may have encountered this. If you've been given a diagram, a schematic, you have to wire it up. It gets very complex quickly because the two don't relate directly necessarily, but we do have ways of making that work. So today our objective is to learn how to convert from a schematic diagram to a wiring diagram using the numbering process. How many people remember the numbering process from first year? Excellent. I'm going to be calling on you guys then for help. And I want you to work together with your peers on this to remind as we go through some of the practical exercises. Well, let's start by talking about some of the characteristics of schematic diagrams and wiring diagrams. Could somebody give me an example, or give me one of the characteristics of a schematic diagram?
The schematic diagram illustrates which components relate to which other components.
Could you be more specific?
Like how certain components changing state, doing whatever, will affect other components in the circuit, whether directly or indirectly.
Right, so we call that the electrical relationship. The schematic shows us the electrical relationship. How is that different from a wiring diagram? What kind of relationship would the wiring diagram show us?
Isn't the wiring diagram more like how they actually look?
How they're actually wired. Yeah.
Correct. How they're actually wired shows us the terminal connections, right? Shows us the identifications on those objects. Shows us the physical relationships. And that is a key aspect of the two diagrams and how they differ. The electrical relationship is easy for us to understand. We can read it from left to right, from top to bottom, and it gives us a very linear understanding of what's going to happen when I alter this or when I change that. I think Dimitri said when we change states. And we can read it much like a book that way. It gives us the information that we need on the performance of the circuit. The wiring diagram, however, doesn't do that for us necessarily, not easily anyhow. Right? It's not as clean because we show every single conductor in the wiring diagram. I think someone was Brandon that said the physical relation, not just the physical relations, like where they are related, say in the building, but also how they look and how they're identified on the terminals. That's not shown to us on the schematic at all. This one's designed to communicate the function, not the physical relationship. One other advantage that's distinct to the wiring diagram is that it gives us the number of conductors we require between points because they're laid out in relative locations. While the wiring diagram shows us the physical look of the object, the schematic uses symbols, exactly, right? These are conventions. They're conventionally agreed upon. They're arbitrary. Right? It's a picture. But any electrician that reads that image knows what that picture means because we've all agreed upon it as a trait. That's its convention. Does that make sense? Yeah. Very good. So, when we're converting between schematic diagrams and wiring diagrams, we need to apply the numbering process. Can anybody recall the steps in the numbering process? Okay, so the first step is to number the schematic.
Yeah, number the
From
first
left to
flyer,
right?
have to see offering your supply.
So what does that mean to number? You said start at the supply.
Yeah, so you
Correct.
start at your supply, and then the conductor that goes from your supply to your first device, that's one. And if there's a branch off of that, you count that as well. And then on the other side of that, it goes 2 to 2, 3 to 3,
Correct. So when we change numbers is when we
change devices.
cross a device, exactly. When we go to a new component or when we cross over a component or a device, exactly. So what we're doing by numbering, so what you're saying is that the lines in between points should have the same number on either end. Much like a conductor. When you go to wire with, say, a 50 conductor tech cable, and you strip it off and you start spooling out all those wires, right? There's core numbers in there that are identified all the way through, and those they have the same numbers on the other end. Same concept here. We want those numbers to be the same. So if we have one wire with a junction that goes to multiple points, they would all have the same number, even though it may take multiple wires to do that.
Because they're connected to the same node?
Correct, because they're connected to the same node. They're connected to the same point electrically. Absolutely. So the first step is to number our schematic, and you literally just start at the supply and work your way across and down. So for me, I tend to work from across the top rungs, and then down to the next rung, and then down to the next rung, and so on and so forth, as a pattern. That way I don't miss anything. One of the problems that we could encounter with numbering, though, is if we have fixed numbers that have been provided to us already, like the 2-3 contact. Right? The 2-3 contact has to be labeled 2 and it has to be labeled 3. So how do we do that if we have more than 2 wires before it?
We use A, B.
Correct. We start going alphanumeric. So we have 1, then 1A, then 1B, and so on and so forth until we get to that number. Exactly. Does that make sense?
Yep.
Yeah. Really, the numbering process is just a way for us to keep track. It's like the breadcrumbs in the Hansel and Gretel story, right? We could call them, this is the cow wire, this is the pig wire, this is the chicken wire. As long as they had the same identifiers on either end, it would make sense, it would work. But in our trade, we use the numbering process. And what we'll see when you go to wire a starter, a motor starter from the field, what you could see is that a lot of that will be pre-done for you. And those numbers will already be indicated. So when you purchase the starter, you open it up for the first time, you pull out the schematic diagram, it's going to be incomplete or partial to indicate the factory wire. And it will have numbers already on it. And you have to add your own control wire that you've gone and done in the field, so the next electrician who comes along can see it and then work from that. You have an accurate representation, and we call that the as-built. Sometimes the red line. Make sense? Once we've numbered our schematic from start to finish, what's the next step? Correct. So we need the physical representation. We need to go to the wiring diagram or make our own wiring diagram of the relative component locations. And then we have to transfer the numbers to the wiring diagram. And this is going to be a way that you can check if you've done something right. You should have the same number of individual numbers on both drawings. So if I have 3 3s on the schematic, I should have 3 3s on the wire diagram. And they may be at different points. And this is, when it comes to motor control, this can be part of the trick, is the wiring diagram. knowing which components exist where. Which is why we spent time going over the starters so much. In first year, we had you disassemble them and reassemble them and look at them and talk about them. Where would the 2-3 contact be? Where would you find the 2-3 contact?
In the control circuit.
In the schematic, it's represented in the control circuit, absolutely. But physically, where would I find it?
Is that like the case for the starter?
In the starter, exactly. Again, the difference between schematics and wiring, that electrical relationship has nothing to do with physical relationship. So you need to take your schematic and identify which ones are where. And that's what this step is meant to do, to help you identify where things are located. Make sense? Once you've transferred your numbers, then the last step is easy. What's the last step? Well, you haven't got the wires on the diagram yet. You haven't created the diagram to wire from yet. So you need to connect the points, exactly. Connect the numbers. Now this one is a little different than what you may have seen in grade school. You remember those connected dots all the way around? And you got the magic picture of the fire truck or the rocket ship or whatever it was. And for me it was fire trucks and rocket ships. Right? Those ones we went 1 to 2 to 3 to 4. But again, as we said, with our schematic numbering, it represents both ends of the conductor. So we have to put all the 1s together, all the 2s together, all the 3s together. Make sense? Right on. Would you like to try one? Yes, please. Let's start with a simple 2-wire circuit. What's a 2-wire circuit? Can somebody explain that?
Hot and neutral.
Basic on-off switch.
It could have a hot and neutral in it. In motor control, a 2-wire circuit does certain things for me. You said it's a basic on-off switch? Yeah, Andy?
Yes.
Yes, it's going to use a maintain contact. It could be a toggle switch.
Probably single phase.
Could be a cam switch. Could be automated. And it could be a thermostat that clicks in and out, in and out. It's a hot and a switch like. What's the characteristic of a 2-wire circuit? What does it provide us with?
Single phase.
Correct, there's single phase. What does it provide us with?
Low voltage release.
Correct, low voltage release. What's the difference between low voltage release and low voltage protection? Which does?
The contact will drop out and it won't come back in if you increase the voltage again.
Correct. Which one is that? That's the protection circuit, exactly. So the protection circuit is known as the 3-wire circuit, and the release circuit is known as the 2-wire circuit. Some textbooks call this under voltage. Where would I want a low voltage release circuit? One that, if the power dropped out, the motor would stop, but as soon as the power was restored, the motor would turn back on again.
Freezer.
Conveyor belt?
I don't know about conveyors.
Like fridges and freezers.
Yeah, fridge and a freezer would be a good example of that. In terms of buildings, I always tend to think of emergency systems,
Fire alarm?
elevators, may not be, because of the motors involved with them, where they're lifting up and down. I'm thinking about ventilation probably.
HVAC.
HVAC systems, exactly. HVAC and ventilation, sometimes emergency lighting. Somebody was in a discussion with one of you the other day and somebody said lighting. Where protection, where would I want a low voltage protection circuit?
Saws.
Equipment.
Saws, equipment with rotating parts, something where if the machine comes back on, nobody gets hurt in the process. Because of that momentary lapse of operation, people have a tendency to become complacent in those moments. And they forget that they shouldn't be leaning on the motor drive or something along those lines. The conveyor system. That's why I was hesitant with conveyors, because conveyors have physical travel, and with that physical motion or travel, we could have somebody getting in trouble. Okay. So what I'm going to do is I'm going to put up a picture of a starter, and we're going to try to do a 2-wire circuit on the board, and we'll do it together. Is that visible to everyone? Can anybody not see that? Can I take a second to warm up and get into focus? No? So this is our starter internally. This is what Dimitri was talking about, where the 2-3 contact is located. But there's more going on inside of here. What's this? Yeah, that's our control transformer. That's what. And what are we going to use the control transformer for?
Stepping it down.
Stepping down to provide reduced voltage control, right, for operator safety. Exactly. So stepping down the line voltage. What's this?
Motor.
That's the motor coil, or the mag coil is actually the mag. That's the mag coil. Right? The motor is somewhere else, outside of the building. Right? This is in the MCC. The motor is out in the plant. What are these? Overloads. Yeah, this whole scenario down here, this whole situation is the overload block. And that's the difference between a starter and a contactor. A starter has an overload block attached to it, an overload relay, right? Which provides us with what kind of protection? Heat protection, thermal protection, right? In case our conductors get hot, which they will if we draw current. So these are the overload heaters, which are connected to a single overload contact. In reality, you could have different options here. Your overload block could have 1 overload contact or 3 overload contacts, depending on the manufacturer and the design. So what we have here should be represented on our schematics, circuit. So I've chosen to go with 1 for simplicity. These 3 here, what are these 3 large symbols?
Normally open contacts that close when the coil is energized.
Correct. What about this little guy?
It's your holding contact.
Correct. That's also a normally open contact that will close when the coil is energized. This is a typical layout on wire diagrams. When the magnetic field builds up around the mag, there's an armature that will draw downward and close those contacts. So all of them work together. That's why they're called instantaneous contacts. These 3 large ones are the primary contacts. Those are the contacts that interrupt the line current in the power schematic. Any other contacts are referred to as the auxiliary contacts. Auxiliary contact meaning extra or secondary or alternative, perhaps, right? For use in our control schematic. So if you only have 1, it will be, by default, your 2-3 contact. So it should be labeled somewhere inside as such. And we'll probably have a couple of terminals off there like that. These are typically mounted on the side of the starter. Okay. So a 2-wire control circuit as a schematic would look something like that. And your book will quite often do this. It'll show the M contact or the 2-3 contact with it. These terminals are going to be X1 and X2. X1 and X2 being the secondary of the transformer. So we have to feed the primary of the transformer, the high side, or pardon me, in this case the high side, the H1 and H2 from the lines. So this is our schematic, and we need a start button. We need that switch somewhere. So let's say the switch comes out of the starter in a raceway. Just like that. First step in the process is to number the schematic, right? Where do I start?
X1.
X1, what do I call it? 1? I'll use green. Is that okay? Can you see the green? So anything connected to that would also get a 1, right? Would you agree that's a 1? And when I cross the device, I change numbers. So that's a 2. Where else would I have a 2? Down by the auxiliary contact and at the mag point. These are all electrically the same point. So they'll get a 2. If I were to cross over the mag, I would go to 3. When I got to the overload contact. And from there, I would get 4, and 4 up to X2.
That makes your 2, 3, 1, 2 though?
Pardon me?
You're normally off the contact under the switch. Isn't that supposed to be the 2, 3?
This?
Yeah.
This is the 2-3 contact. So we're not using it. It's non-functional in the circuit. If I were to connect this around the switch, and we close the switch, turn on the motor, it would start just fine. But when the mag is energized, this contact would change state. And if I went to open the switch, what would happen? It would continue to run. I would seal in around my control device. So we can't do that. The only reason the book shows it to you is to remind you that it exists and not to connect it. As strange as that may sound. And we've sort of trained you to think about never sealing in around stops. We have to be careful now, because when we get into float control a little bit later, it's going to seem strange, because we're going to get you to do almost just that. It's going to look very similar to that, and it's going to seem counterintuitive. For this case, we're going to be open. There's our numbering schematic. Let's find the components. Where would X1 be? On the transformer. Here, I'll tell you this is H1 and this is H2, making this X1 and X2. So here's 1. Where else do I need a 1? At the switch. Is that it? Just 2? What about 2s? How many 2s do I need? 3. Where are they?
Other side of your switch.
On the other side of the switch, I heard. At the mag. At the mag. And at the contact, which is already there. That was given to me. When I opened it up, that was stamped on the component. Very good. What else do I need? Correct. I need 1 at the mag and 1 at the overload. And we have to be careful, because I chose to use 3 here, but in fact we have a 3 here. So we probably should have chosen a different number. Sure, let's call it 3A. That would make this 3A, 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 3A. Excellent solution. Where would 4 be? Other side of the contact? And then the transformer. Very good. Now all that's left to do, connect the numbers. Can I use the green? Is that okay?
No.
No? Blue it is. I have one here, so I'm going to pick up a wire from here. Okay? How many twos do I have?
Three.
There's one here. I could make the connection there. This would be a terminal point, internal to the starter. And then I would take it to the mag, right?
You wouldn't actually wire that too, because you're saying you're not using it?
No, but it's a point where I can make a splice. It's a screw with two slots in it where I can put two wires underneath and then clamp it down. So I would actually wire it there, or on the terminal strip if there was one provided, representing that. And I'll terminate there, but I will not terminate the other end, just like we have here.
So you do that instead of just going straight from 2 to the 2 at the coil there?
6 wire and having an extra wire.
Okay.
So you're saying don't connect it,
Well, just because you're not
and go around.
using it.
Correct, it's not in use, but the schematic diagram shows it connected. So I'm wiring according to what the schematic diagram is illustrating. So I have to connect it because that's what this is asking me to do. You're right though, practically, you don't need the 2-3, maybe just not utilize it. From there, I'm going to go to the 3/8, of which there are 2. And then from the 4, that hole, right?
Yep.
There it is. We can see why it's called a 2-wire circuit, because when we look at the raceway, there are 2 conductors inside the raceway. Make sense? Aha, and a switch leg, as we said earlier. One of the advantages to the wire diagram. When I go to build now, if I have to run the raceway, I can check my code, I can see what size of raceway I need to put in, right, which is dictated by the number of conductors. And then I can put it out like that. Or if this were cable, then I can purchase the correct cable. That was an easy one, eh? Try another one? Yeah, let's try another one. Let's do a 3-wire circuit. Can somebody tell me how to wire a 3-wire control circuit? Schematically?
From X1 to your normally closed push button.
Normally closed push button, absolutely. That's the stop. From there,
Your starter.
start button, what kind of button is that?
Normally open.
Normally open. Is it in series?
Yes.
Yeah.
Okay, now what?
Each side of the start.
Travis said from each side of the start button, have a 2-3 contact or an auxiliary contact controlled by the mag. So sometimes this is called 2-3, sometimes it's called just M. If this were a control relay, it would have to be called CR. They have to associate, correct? But 2-3 is conventional, as we've just seen. From there, where do we go? Not quite. To the mag. The coil. I like that. I'd rather call it coil than a mag in some ways because it gets us away from that M. People tend to call this the motor, and it's just not a motor. And from there,
Coil.
the overload contact inside the starter. Very good. Ready? Let's number it. Is that too small? Can you see that? Okay. Yeah, that's good. It's not bad. How do I number it?
Starting start.
This is why it's called the 2-3 contact, why they're stamped that way from the factory, because 3-wire control, low voltage protection circuits are the most common circuits that we have. What's next? Well, 3's given to us, and you said, so if that's a 3, then they would all have to be 3, exactly. But it would follow our normal process as well. 3, and then 3 here as well. Correct? Yeah.
4 and 3 on a coil.
Can I do this? Are you okay if I do this?
Yeah.
And I'll write it twice so when I transfer it, I don't forget to put 2. And then
Coil,
K. Somebody said, oh well,
OL to X2 for 5.
for 5. So we'll put 5 there and a 5 there.
Is this why you're offering us tape in the motor lab yesterday?
That was why it was tough. You tape in the motor lab, yeah. So you can do this practically. I mean, one of the things about wiring, we'll take a little diversion here for a sec. When you actually go to wire, you get all those wires snaking all over the place. It's going to be hard to tell what they are. Okay? And so then your next step is to go through your diagram and trace the wires. And you're checking them off your diagram, making sure you have them all. But how do you find the extra wire? The bonus wire that you stuck in there by accident, that's not on your diagram. You can't. And that's the one that's causing you trouble with it. So if you have the numbers on them, then you can find the bonus wire. Because it should have no number on it. Does that make sense? Cool. Let's transfer our numbers. That's our next step. All right, the next one. I'll do that one for you. Where's the next one? Oh, I guess we need a race.
Yeah.
Some buttons. There's our raceway.
Might as well change that to a 12.
There we go. You okay with that?
So, you're gonna put on the bottom controller that you just put in. You're gonna put a on the side closest to you on the bottom.
On the bottom, on this one?
Yeah,
What do we call that? That's the,
that's your stop.
yeah, that's
Really close.
the normally closed contacts on the push button. Remember that actually, in reality, our push buttons kind of look like this, don't they? We have 4 terminals on it. We have the option to go from normally closed or normally open. So you want to go here? Is that what you said, Michael?
Yeah. To the one.
And that would make this the stop.
Yeah.
Okay. Well, I changed to blue. Sorry. What's next?
Did you change the top one to a normally open? Or I guess it still is.
No, at rest it will sit like that.
Can I go 2 side of the stop to the bottom side of the start? For 2?
To the bottom side of the start, could I go here?
Yes.
Could I go here? Does it matter?
No.
No, because it's a series connection, it doesn't matter which one I choose. Exactly. Let's go to this one. So we're somewhat linear.
2 also needs to go over to your 2-3 contact inside.
Right. Let's make this 2 here.
And then the 3 on the other side of the start.
Is that all? 1, 2, 3, 1, 2, 3?
Yeah.
Sorry, Travis?
So a 3 from one side of the start, which is opposite side.
This is our start here.
Here's the other side of your,
To there. And at the coil, we're good, there are 3. Other side of the coil gets a 4.
Over to your left.
Overload gets 4.
Other side gets 5.
That gets a 5. And what are we missing?
Other side is yours.
The transformer. Very good. Now, we should be aware that quite often the connections from the mag through the overload or overloads are already done for us. It may actually even go all the way back to X2 for us from the factory. But you should check those before you go to wire one. Last things to do. Connect the dots, connect the numbers, say 1 to 1. That. 2 to 2. Uh-oh. There's a 2.
That one's over by your 2-3 contact.
So you could just go off the stop button contact.
I could go off the stop, I could go off of here. I could also go off of here because these are the same quite electrically. I could pick and choose. It's going to be the easiest way for me to do that without crossing over. Let's go this way. No wonder. Like that. Good. And then 3 to 3. Well, there's a 3 there. How many 3s do I have?
3.
So where's the last one?
Start button.
Back here. Ah,
There you go.
there it is. Okay. That's good. So there's our 3s. And then we just have to do, again, what was probably done from the factory. 4 and 5. Very good. And we can see clearly why we call this one 3-wire control and 3-conductor control. Make sense? Are there any questions?
Only what happens when you add 2 more
2 more what?
start-stop stations.
Or a single start stop.
If you were to add a stop into your thing, it has to be in series. If you're
Correct.
to add a start, it has to be in parallel to your start button.
Correct. That's our convention, right? Well, that's how we wire them. Our stops are always in series so that any single break in the circuit will de-energize the mag, or any parallel path will start the mag. So you said, how would we do it if we had another stop-start station?
Yeah, that's fun.
Yeah. Well, that's a homework question, isn't it? Wasn't that in your lab conclusion?
Yep.
Well, it sure is. So I'm going to let you work out that one on your own tonight, now that I've shown you the process. And I'm going to give you one to work on your own. Okay? Or in pairs. How would you get in groups? I'm going to put one up here. I'm going to get you to work through the process together and see if you can do it for me, and I'll float around, make sure everybody's okay. We'll spend 10 minutes on that. Okay? And then we'll go over it. Here's your schematic. There's your schematic. You should be familiar with this one. This is X2. This is a jog circuit. It's a run jog circuit. So let's imagine that we've got our raceway coming off of here, just as before. And when you get to the box, you open it up and it's got some terminals in it. And when you look at the cover, it tells you that this one is labeled stop, and this one is labeled start. course, this is run job. Okay? Feel free to work in pairs. I encourage it. I think it'll help us get a better understanding. Give it a try, and I'll float.
Not to make a difference. You seem to get it. Cody, did you guys do this after the schedule? This isn't just good control. You go to the house and does certain things. How do you see it get this?
Yeah.
Someone's getting caught up in my
Yeah, just duck. Fine, just duck.
Yeah, sure.
When you're doing the numbering system. So if you do 2, 2, 2, do you start number 3 on the other side of your start button or on the other side of your stop?
3 is given to you at the contact.
2.
Yeah, so it'd be 2, 3.
Correct. 2 and 3 have to go down.
So 3, 3, and 3 obviously on this side of the contact as well. So then would this be like a 2A or a 2B? As you cross your device on
Well, that is 2 as well. You roll 2 and give it power.
Stealthy.
That means you discount the 2. Yeah, that's the
That's
Close contact.
Okay.
Or closed.
That's what I was getting at.
Yeah, like, I would just pop over.
Then things started making sense.
No! 3A or 2B.
Thank you.
So that makes you fall back on the off line. You got it. Jordan?
Yeah.
Making sense?
Yeah.
Right on. What's that? Oh, it's a unit control. Right on. Yeah. Does it make sense? Yeah. Whoa.
So that you can jog
Kind of figured.
They're not reasonable.
Why would you be sorry?
which means when you press the start button, or leave the string it up here. But as soon as you
The other thing is we're given
Oh, you use one of these?
Yes. So I can maintain my 2 feet contact.
Oh, I see
That's why it's turned down. So we press the start button. Turning the motor on, it's closing down. It's no, that still closes. Yep, because it's a mechanical connection. So when this energizes, it closes off the wood. It still closes. But the circuit.
Oh, okay, right.
It still physically changes state. Correct, because that's what's sealing in, exactly.
Oh, yeah.
Lower the ceiling.
What threw me off is after the start
What would we do about this terminal? You would use that for another function. So this was instead of auto.
Yes, we got like the highest mark in the class, so 100%. Scaled it, colored it.
Yeah.
Pretty sure.
Like electronics. We didn't have to spend a lot of time on it. I would bet most of it
Oh, yeah. It's almost like
shop. Which is why I wish I would try and read on class if you can. So we can get to that. See some of it.
and then there's wood everywhere. No.
What's going on? How do you do?
Great.
I don't think that thing through. Yeah.
Oh.
Thing you do is
Yeah, it's weird.
Oh, really?
Because you're fixed on 2, 3 here.
I didn't even look
So it's not too big.
That's basically.
Right. But let's say it wasn't right. Let's say this was actions. When I was here, the run circuit was just control the start. Second position was an auto. Maybe it was auto. Then that would happen before. So basically it was free. So
The whole time, but are they, they're outside? Yes. Is it?
No, because the right side, that's what goes north, that's the one up to left. I've been getting
Plug and play with that.
Oh, really? Just in the mirror, instead of trying to do fixing the color?
It's like, what is it, a 10?
Okay, looks like everybody's had a chance to wrangle with this. Let's run over the answers and we'll see how you did. It seems that everybody has a pretty good grasp on that. We must be happy to see. Let's number it together. Here's a 1
Yeah.
and a 1. What do we need to do next?
Well, you have to go to 1A because your 2 is pre-marked for you.
Correct. 2 and 3 were given to us, so pre-marked, as you said. That's a good way to think of it. So the 2 is here, making this also a 2, making this a 3, and this a 3. So that was already done for us. We have to follow that convention.
I started with 0 actually, because it made it a little easier. We don't have to use letters. But I don't know if that's okay.
Well, when you go to starters, you're not going to see the number 0. But you will see 1s, 1As, 1Bs, 2s, and 3s. Typically, don't use the 0. And that may be because we reserve 0 or O for an XO point on a transformer. We don't want to confuse the issue with that very specific designation. But you're right in that you can call it, as long as you call it whatever, you will be able to make it work. So, that's the donkey. What about this wire between stop and start? I heard somebody say 1A, right? Yeah. That's what I thought I heard. And 1A making this also 1A, correct?
Yeah.
Right. And then from there, go back to our 4s and 5s that we saw previously. Let's throw the numbers up on the board. 1. Where is the other one?
Stop.
Here's the stop. Normally closed. Doesn't matter which one. Whatever makes it look neater. Could we go here? Yeah. Sure we could. It just means we're bringing energy into this point before this point. So this is our controlled side. This is our line side. Correct. And be careful when you're in the lab doing this. It can be easy in the moment to connect things and then forget which side you're making connections to. And if you misconnect the wire to the wrong side because it's laid out differently than the way you had initially visualized it or your diagram shows it, it can be confusing and problematic. Very good. So what's on the other side of that? 1A. Where else do I have 1A? At the start of the jog. So the start is normally open, so I've got to use these two. Can I go here?
Stick to the same side as the stop.
Why? It will come out neater. Exactly. 1A. And I have another 1A as well. On the jog, on the common terminal of the jog. Absolutely. Very good. Now what? 2's coming from the start.
Sorry, 2 coming from
2 coming from the jog. I agree with that. There. To the auxiliary contact, the holding contact, the sealing contact, the maintaining contact. It goes by all those names. You bet. Where are the 3s? The other side of the contacts. Start. Right here. On the normally open.
And on the other, on the left side of the mag?
And on the mag or the coil, very good. And then finally, just like before, 4, 4, 5, and 5. We can see why this part is wired for us, because it seems to be repetitive, okay? It's the same thing over and over. So factories can rely on that. It's the other side of the control they can't necessarily find. Let's make our connections. 1 to 1. I'll do that one. Now what?
1A.
1A, 1A, 1A.
Very good. So this is what Tyler was saying. Oh, sorry, Travis, pardon me. If the 1A was over here, now we get wires moving around a little bit. It's not quite so neat. Sorry, Travis.
2 to 2.
How many twos?
2.
Just 2. So 1 wire. Uh-oh. Uh-oh.
We get ours the other way around. Can you have the 2 on the bottom, 3 on the top?
Yeah.
Sure.
Yeah. So you
Sure.
have to-
I just did it that way because that's the way I did it. In reality, it'll be fixed, so you can't flip it over, right? And your wiring diagram should reflect the actual location. So I'm not gonna change it because I want to emphasize that point. What about 3? How many 3s?
3.
3 again. So let's
Go from the start to
do this. The contact.
Contact to the mag.
And as we said earlier, we said that there's a good point for a splice there. Let's go down to there.
It's not the same for the water flow or anything like that. You just have one right from the wire or you do a couple.
No, you could make the double connection here on most starters. In reality, starter manufacturers come a long way from this, where you actually wire to the components. When you pull out a starter block, and I'll take you down to look at one when we get back to the shop, you'll see all of the components are laid out roughly in this location, except now they've put all of these terminal points down here, just a strip of connection points.
That's what we had.
Right. Yeah, and it's been that way for a while, where we go 1 all the way through whatever's available, and then the factory wiring is coming off to those points. So we just have to wire the terminal strip. However, when you receive one on site, whoever your quality control person is, or your journey person perhaps, whoever's in charge of that aspect, will always verify that the wiring from the factory goes to the terminals it says it does, which is why you need to understand where these points physically are inside the starter. Because if you got one that was manufactured by somebody who wasn't paying attention in that moment, it could cause catastrophic issues. Okay? By the way, how many wires do we have in our raceway?
3.
3 wires again. This is 3-wire control. This is a really good one to look at, because before we had 3 wires, we had low voltage protection. So if you have a circuit that's currently operating on a 3-wire circuit, where you have the low voltage protection scenario, and then the employer says, I would like to put in a jogging option on this motor, really, you don't have to change the raceway. You probably don't even have to pull new conductors. You just have to change the hardware attached to the end of the raceway. Put in a new enclosure, put in some new devices, and it's a time saver if you understand how to do it. Remember the dangerous jog circuit that we had before? That was one of the reasons why people went for the dangerous jog, so they didn't have to change the components. They would do it with push buttons. But as we know, it causes other problems, right? That run. Okay. Where we're going from here in the next lesson is we're going to take this process and we're going to reverse it. Okay? We're going to go from a wiring diagram to a schematic. And it's the same process, it's just we do it in reverse. Okay? So what I want you to do is I want you to, for homework, have a look. PDF's gone. I want you to have a look at Learning Task 4. Sorry, guys.
Kids are ready.
Learning Task 4 in I2. Self-task question number 5. Okay? That's homework, and it's going to reverse the process on you. See if you can wrangle with it, we'll deal with it when we come back. Thanks for paying attention. You guys should now be able to functionally convert your schematics to wiring diagrams.